in this area of software engineering, there is no denying that artificial intelligence has come to stay. You know, from the rise of AI models as far back as 2017, when Google came out with the transformer model, we've had series of iterations of AI models with Google first setting up their Google Assistants. At that time, that was around 2017, 2018, where they first launched the Transformers architecture model that they used for their AI training and yeah. So from then on, ChatGPT came up. They took the research as Google had initially done, and from then they went on to build their own models based on the architecture that Google provided. So now we have come to a place whereby AI models are very good at doing tasks, generative text. So initially when GPT came out, I remember it was a wave at then where everybody was surprised at what AI models could do at that point. So when ChatGPT came out, it was generating text, it could answer questions, it could give feedback, it could based on them. So the training data they had, at that time it was limited training data. So basically OpenAI trained the initial version of ChatGPT from data from a particular previous day. So the AI models then the AI model then didn't have access to the internet. So it was all strictly based on training data. So OpenAI trained GPT, the initial GPT version, based off data from the internet. So that was how it also everybody was blown over by how AI was growing. So I think ChatGPT had the largest growth ever for any application or any product ever for any business. So it was in wave, and they released several iterations. They released GPT, so then they released GPT-3. GPT-3 was a much more capable model. So ChatGPT made the model bigger, trained it on more information, and all of that. So, but initially, I think the major milestone where AI now had a foothold that people now started to realize that AI is not going anywhere soon was when they launched the GPT-4 model. The GPT-4 model at that point was extremely good, right? It was one of the that was when people could see that AI models could grow from becoming just a generative text to being much more as an assistant. It could help you perform tasks. So that was where agentic tool use came up. So it's what they call agentic tool calls. So it's whereby an AI model can perform some certain tasks, right? So let's say originally the initial versions before that they could just generate text, right, based on the training data they had. But now with the era of agentic tool calls, it means that AI models can now do much more than what they were trained on initially. So that's now helped AI models to be able to adapt to real world actions adapt to actions in real time and help users to perform major tasks. So that was also when we had the era, or that was also when, because of the agentic tool calls and the tools that it had, that was when initially we now had the first, technically not necessarily the first, but like the first major AI in tech. That's major first AI in programming, in the field of programming. That was where we had the GitHub Copilot. So as at then, it was more of like an auto-completion where you could write a code and it auto-completes maybe you have a function, you write the name of the function, it also completes it for you, and it could help. So that was when people now started seeing the use cases that, oh, AI could be much more helpful in this software engineering space. So GitHub Copilot was that was where people knew that yes, it has come to stay. So from then on, we now started having other labs and other companies start creating softwares around AI models for programming, for software engineering. So that was where we now have several options. So from then to now, we've had a significant growth, and we have some companies that have one of the best AI models in terms of mathematics, code, and reasoning. So I'm a software engineer. I've been a software engineer for up to 8 years now, and I've been writing code. I write different languages. I build softwares. I build mobile apps. My own workflows, I don't tend to stick to one particular model. There are people that would say, oh, they use only this particular model. So I tend to be much more dynamic in the way I build, in the way I integrate AI into my workflows. So, but there are two primary models that I enjoy using the most. Those are, although they are, because of they are most likely the recent models first. The first one is GPT 5.3 Codex. So, right, but we have the normal GPT models, right? The latest one that is 5.2. We have the GPT 5.2 model that is the latest. OpenAI created the alternate version for that specifically trained for code. So we have the GPT 5.3 Codex, which is extremely good for agentic programming. And we have from Anthropic, which is the Anthropic has different types of models. They have the Haiku. Haiku is the lower the least intelligent version of the model of their models, but faster. Then they have the Sonnet, which strikes a balance between performance and which strikes a balance between intelligence and speed. Then we have the Opus models, which is basically their highest end models, and they are basically used for long running tasks, heavy reasoning tasks. So, but the two models that we're going to be looking at today are the GPT 5.3 codec from OpenAI and the Opus 4.6 model from Anthropic. So I have like a short demo that I will use to show what these two models are also and how I use them. So basically, how I use these two models are like, so for 5.3 codex, because these two models, they are built by two different companies, so they have two different behaviors and how they tend to write code, right? So, but I use a mixture of both depending on what I'm working on. So for 5.4 GPT 5.3 codex, it is a much more software engineering centric model, in the sense that it tends to take its time to make sure that it's getting everything correct before it actually tells you that, oh, I am done with this particular task or that. So it's much more it takes its time, right? That's one of the critiques that OpenAI has with their GPT models for now, is that they are usually slow. They usually get the job done, but it's usually slow most of the time. But on the other hand, the Claude models are usually very, very they are usually fast, but they are also now they also perform their tasks. They also perform their tasks. They do their tasks well also, but they are more expensive because the Opus models are not cheap to run. So let me show you the cost of let me show you just the cost of these models, the way their cost of the models actually. So this is let me check it on Open Router. So let me go to Open Router models. So this shows you how much these models cost to run, right? So GPT 5.3, although we don't have GPT 5.3 is not available on Open Router. Open Router is where it's a hub for major AI, it's a hub for AI models where you can see all the available models and all. But for now, the GPT 5.3 codex is not on Open Router because all the codex models are exclusive to OpenAI servers. But now with the Opus models, so the ones that are open exclusive to Open Router are the normal 5.2 models. So the normal models without the codecs, those are the ones that are available on Open Router. So, but the pricing of the normal models and the codex models are similar. They're usually the same pricing. OpenAI gives them at either similar pricing or gives the codex at a lesser pricing. But the Opus models are usually very, very expensive because they perform more. So, but let me show you the latest model that we have from OpenAI is the GPT 5.2 model, which at the time of this recording costs $1.75 per million tokens for input and $14 output. So the cost of input and output is that the cost of how much tokens are going into the model and the cost of the number of tokens that are coming out of the model. So they have different pricing. So GPT charges $1.75 for per input and 14 outputs. But now let's compare it to the Opus model. So the latest one is Opus 4.6, which now you can see here it costs $5 per input per million input tokens and $25 per million output tokens, which is crazy. But I mean, but the models are actually very very good. You understand? So it's more of like a pick or choose situation. You know, pick which works best for you. Are you willing to pay for higher the price? Because there are people that have had this experience that, oh, Claude models are actually very very reliable for them for coding. They rely on it. So it just depends on which one you use best. But I use a mixture of both. I don't stick to one. It depends on what I'm working on. Maybe it's front end or back end task. For front end tasks, I prefer using Claude models because Claude models tend to design better than GPT models. Although currently I guess the best model currently for front end design is Gemini models, but Gemini models are a bit unstable because I'll be using the Gemini models in Antigravity, and it has been quite funny. Let me say it has been quite funny. The model tends to behave a certain way. Sometimes, most times, it gets the task done, but it's not very, very reliable. If you are going to be using it consistently, it might tend to misbehave at some point in time. But the Opus models are the Claude models and the GPT models are usually extremely stable. So, but now I'm going to be testing these two models to see which one will actually do better. So I have like a prompt. I have a prompt that I want to use to generate. So basically, I want them to build a landing page, a website for a particular photography business. So this is the prompt. I've given it. I said, create the landing page for a photography website. You can use images from the internet and make it beautiful, unique, and modern as possible. Use your design skills for this task. You have to use Next.js and Tailwind for this task. So the reason why I told it to use Next.js and Tailwind for this task is because I would have told it to just use normal HTML and CSS and try to design it whichever way you want, but that way we would not get the best. We would not be able to see how these particular models make use of agentic tool calls. So agentic tool calls is the ability for a model to perform actions in a system. The model can decide to read a file, it can decide to edit a file, it can decide to maybe search the internet. That's so I tailored these two prompts for these two models. So you can see here I'm using VS Code. I'm using the Microsoft Copilot on VS Code. As here on the first window, I have selected GPT 5.3 Codex, and here I've selected Opus 4.6, Claude Opus 4.6. So we are going to be running these two tasks, and we'll see how well they come about. So from what I've used so far, right, I can say that I'm sure that Opus 4.6 will come out with a much more better looking result. But what I want to show you here is how these two models behave. So you can pick and decide which ones you want to use. If you decide to use a combination of both, just like me, that's fine. But this just shows how these two models behave as regards to agentic tool calls. Maybe in the future, I might throw in a Gemini in there. So I'll show you how Gemini also behaves when it comes to agentic tool calls, because this is what is going to make AI to be able to function properly in the aspects of software engineering. So let me run these two commands. So yeah, so they are both running now. Okay, yeah. So VS Code has this thing where by default it decides to select MCP servers. I don't like using MCP servers because that's the story for another day. I'll explain why I don't like using MCP servers first. I'll show you. But now they are running. Okay, so you can see they both started their work. So you can see here now, Codex is reading. So you can see, okay, they are giving me commands to allow to run. So they are trying to run commands now to set up the whole project. So I'll just allow them to run their commands. Why they are running, right? Let me just explain. So these two different models have different ways they operate. So originally, what these models do is that currently the current AI models that we have, they do what we call reasoning. So reasoning, the way reasoning works in terms of AI models is that initially when GPT models came out, you could just ask the question and it responds immediately with the answer. But now, because of that, at that time, the data tends to not be accurate. So GPT came up with the idea of reasoning. That's whereby they make the AI model to generate some tokens first, some information first. Then you just reason some data. So you generate some tokens that the model now tends to read again to make sure that those data are correct. So that's what we call reasoning. That when you get that an AI model is reasoning, that's basically just what you generate tokens that it now refreshes again or reads again to make sure that it's returns the actual data is supposed to be there. It's more like a reconfirmation, right? So that's basically just what reasoning is in terms of AI. So, but now the difference between the GPT models and the Claude models is that for Claude models, the reasoning data is available to everyone to see. So with the Claude models, you can see the reasoning data, right? You can see the reasoning process behind what it's trying to do. But with other AI labs like GPT, Gemini, they don't give you those, even Grok, even SAI's Grok, they don't give you those reasoning data. They just give you a summary of those reasoning data. They don't give you the exact reasoning data. So that's what they do. So okay. Yeah, VS Code has some weird bugs. So from now, I can see that it has some UI bugs. It's trying to do the layout. Okay, I think it's stuck actually. So Claude model now is stuck here. Weirdly enough, so you can see these models are not usually as reliable as they will be. So they still need a lot more steering from a software engineer or from a developer to actually make sure that these models are doing the right thing. That which is why, in my opinion, I'm very sure that AI models are not replacing anytime soon, because these models just make a whole lot of mistakes. Now I have to manually allow Claude to continue, because Claude cannot continue from here. I will have to select it to use. Would you like to use? No, let it not use. So it has put it's continuing now. So you can see these models tend to not be very reliable. They can be reliable whenever they feel like you get. So that's what they are doing. They are still running. So let's see what we have here. Codex has set up. You can see Codex has set up the file structures that we have. This is the basic Nest.js file structure that we have. Yeah, so you can see we have the basic file structure. We have the default code that is in this particular project. Right, this is the default Next.js project. So here we can see for the code that is generated also, but you can so that generated is basically the same thing they both generated from that, because they use the same commands to create the code. So but they are still installing their dependencies. This might take a while, so I'll just fast forward the video from this end. When they are done, we'll come back. Okay, before we even go right now, you can see so Claude models now. This is now it's trying to echo waiting for install to finish. Why are you have the result of, you see, so basically you just killed the process. Claude model the Claude model killed the process, and it's now trying to sleep again after you have killed the process. So these things are not usually very stable. They still need a lot more steering and a lot more watching over. You have to watch over them and make sure that they're not doing the wrong thing. There are cases already where people said Gemini models deleted their whole code base. So things happen. So yeah, but I'm trying to make sure that thing doesn't happen. So yeah, it's still running. I'll just skip all these parts. Okay. I guess we are back. So now the Claude model, I don't know if that's finished installing the. Okay, you didn't install the node model at all. You just skipped and said reasoning. So now you can see it's now reasoning on how it's going to create so let me just close this file. I don't think all these are necessary. Let me expand it. So now you can see that it's reasoning on how it's going to create the website structure. Although it did finish installing the package, but let's see what it will come up with once it's done. So, but now it's making some changes to some core files. It's styling the website basically. Why the GPT 5.3 codex is still waiting for the installation to finish, right? Because technically the GPT 5.3 codex is behaving as it should, because normally you would wait for the installations to finish before you proceed, but the Claude model just killed the process and went on to start making edits to the file without confirming that the installation process was actually successful or not. So yeah, so let them just finish their setup process. Okay, so I think the Claude models is progressing. So now we can see that it's now creating some several parts of the website. It created the nav bar already. So let me minimize this a little. Let me minimize this first. So you can see it already created the nav bar. Although these errors, it will look at the errors later and try to fix them. But for now, it's still creating the files. The GPT model, the codex is still trying to wait. It's waiting for the process to finish before it proceeds. But yeah, so Opus is already creating the file. So these are the two things you get from the two different models, right? These are the kind of behaviors you get from them. The Opus tends to, it's more of like, Opus is like that eager co-worker that is willing to jump on tasks and finish them as soon as possible and make sure that she has built several things or he has done several things. That's how the Claude model behaves. They want to just do tasks and show that, oh yes, they have done this and that. But the GPT-5 code, the Codex models, they usually tend to be much more careful and in their behavior, in what they do. It tends to be much more careful. Codex is willing to spend a lot of time planning and making sure that everything around it is favorable for instance. So you can see now in the Codex model, like that's finished, you waited for the solution to finish. Then now it's now proceeding to, yeah, so you can see it said the project scaffold is ready and I've reviewed the base files now. I'm replacing, so now it's replacing the default app now. It's proceeding to now create the pages, which the Claude models are already started initially, but just now that the Codex model is now proceeding to do that. So now it's creating the files that is going to need to create the UI elements and all. I didn't give them a component library to use because I want to see how they would build it naturally. Because component, if I giving these models a component library, they will most likely stick to the styling that the component library provides. So that's why I didn't give them a component library. I want them to build it from scratch with Tailwind. They should design from scratch with Tailwind. That also shows how they think of these particular types of tasks. So yeah, so we can see that the codex Knight has created its first file. It replaced the contents of the file first of all. So it's it has added a whole lot of data. So it has added, I think it has added a navbar. I think I saw a navbar up here. Okay, it didn't add a navbar. Strangely, it only added the main section. It didn't add the navbar. That was quite weird. But let's see how it goes. Probably it's not done. It's not done building. But so now the codex model is not trying to check for error. So he's trying to see if there's anything that's missing out. So he's trying to build. So let's let it finish running. From what I'm seeing here, the codex model compressed everything into one file. All the basically I just need to build a website, right? I need to specify how many pages and all that. So Codex went ahead and did one. It went ahead and created only just one page. But from what I'm seeing here, I don't know if the Opus model is doing the same thing. Okay, yeah. The Opus model is doing the same thing, but now it's much more structured that it's created components for the different sections. So this is why I say that Claude models are usually generally much more better at front-end projects than GPT models. GPT models, Codex models are extremely good at back-end projects. So yeah, that's the difference between the two of them, basically. So, but they both have their give and takes. So now the Codex model is complete. So let's run this. Let's run this particular one and see what it did. Let's run it and see how it did. So I think it used npm. It didn't use pnpm. It usually does default for npm. So I'm running the server for the Codex version. So we'll see how it looks like and we'll compare it to. So I think the Opus model is still running, which is quite strange because it started before the Codex model. But I think the Opus model, right, is doing much more work because frankly the prompt we gave it was not extremely specific. It was not specific at all. It was a very vague prompt in terms of what the website should do and all of that. But I think the Opus model is willing to go the extra mile to maybe add more things that you might not even have thought of, right? But Codex models are still as strict. So Codex models, like I mentioned before, Opus models are like that enthusiastic developers, the developer that just wants to build things and just make it. Like that's just the way Opus behaves. But Codex is a much more detailed centric model. So if you don't tell Codex to do something, it won't do it. It might, unless maybe the thing you did specify is actually critical to what it needs to do, then it's doing. But if you didn't specify, it won't even process. So you can see it's asking to continue. So it will the Opus will continue from there. But let's see the results of the Codex design. So why that is compiling. Let's see what Claude. Okay, Claude now is still creating more files. Okay, Claude is just starting now to edit the main file. So it has created, although it has created the components already beforehand, it created the components beforehand. All this is showing red because Claude has not realized that it forgot to install the dependencies, the packages before starting to write the code. So that's why it's showing on this. I want to see if the Opus model will figure it out by itself. But so it's asking to run more commands. So I'm assuming that in the process of running this, asking to run this command, it will figure out that it has it, because if it doesn't, then I don't know. That would be a very, very weird behavior. So this is what Codex came up with, right? So this is it has the this is actually not this is actually quite not bad. This, but I mean, it's just basic. It's more of like what you would generally see. So you have your logo here, you have your navigation here, you have your. I don't even think it picked the right font, but I mean, I'm being too critical. But let's see what's supposed to come up with. But we have this section here. We have the main section. So, and here this is now okay. I can see like I added like a glossy effect under this. Then okay, do this click? Okay, these images don't click. This image is never showing at all. Then about studio, let's create. I mean, it's basic. I mean, for just a very big prompt, I think Codex. And this is a good starting point. Actually, this is a very good starting point for you to go, because generally when you build when people see websites built that AI, they know that you definitely see that your purple gradients. Every dev that builds AI knows of the purple gradient pandemic. We call it the purple gradient pandemic, whereby any website you build with AI without specifying how you want it to look like, it all comes with the purple gradient, blue and purple gradient. But let's see progress on the Claude models. So it's still running build. It only install the dependencies yet. This model is charged based on the output tokens, right? So this is going to cost more. Opus is going to cost way more for a task that Codex has already completed minutes ago, and maybe might need more proper prompting for it to now show properly and all of that. So I will definitely give them the follow-up prompts. I'll give them the follow-up prompts on what to do, but I have to wait for Codex. I have to wait for Opus to finish first. So I think Opus is actually stuck here because it's still waiting for the command to finish running. Okay. The cloud model is asking for to run the command again to sleep. What is it trying to sleep? Build wait done. It's trying now. Okay, now it's not trying to figure out that. Now it's just realizing that there is no node modules, right? It didn't install the dependencies at all. It just now is realizing that. So it's trying to install. It just figured out now. It's still trying to find it. It's not finding it. It's running multiple commands because it's assuming that it installed the dependencies before. So, but it's not sure exactly. It's now running the install command to install the dependencies. They'll be trained on large information, right? So it's you don't expect they can't do much more than what they've been trained to do. So that's basically just what they are doing now. Let's just wait for the command to finish running. This glitch here, I think, is a VS Code glitch. So that's why I don't specifically use VS Code for major work. I prefer using Winsoft for major work. But if I'm to run this Opus task in Winsoft, it's going to finish on my credits. So I prefer to just run it in GitHub Copilot, because I think I have like some credits that I haven't used yet. So well, let's wait for this to finish running. The cloud model is still waiting for the installation to finish. So it's trying to install the dependencies that are supposed to finish. While it's still trying to install. So there are some other models, right, that I use that are not technically the high end, but they are usually good for maybe minor tasks, because yeah, as you can see, these models tend to be more expensive, right? These Opus models and GPT models. But I mean, 1.75 dollars per million input tokens is expensive, and considering that you're paying $14 per million outputs, it's going to cost you when you're doing large tasks, or when you're now doing some minor small tasks that you have several small tasks you're trying to finish up quickly, using these models like will cost more. So there are some models also that I enjoy using for maybe minor tasks, or maybe to pass through maybe like large JSON data for me, or to do some maybe like some small tasks that I don't need the highest of intelligence, but I need speed and you get. So there's some models I use. There is the Minimax model. So I enjoy using this Minimax model. So this Minimax 2.5 model, it's a smaller model, but it's extremely good, right? I mean, it has in terms of software engineering, it's not as good as the Opus or the GPT models or the Gemini models, but they are actually good for some certain tasks. So you can see here on open router for academia is number 8, finance number 9, programming number 1. So it means that people are actually using this model for programming. Majority of people are using this model for programming. Let's even look at the rankings. So okay, yeah, this is the programming ranking. So you can see that the Minimax 2.5 models is actually the Minimax 2.5 model is actually good. 656 billion tokens generated. That's crazy. And the model just launched last month. I believe the model launched last month or so. So accompanied with the GLM5 model. GLM5 model too is a very good open weight model. So these models they are called open weight models. The difference between proprietary models and open weight models. So in the world of software engineering, we have closed software and open software. So we have open source, we call them open source software, and we have closed source software. So open source software are software that their code is available to everyone on the internet to see. Any developer can make contributions to those particular projects, and their features are added. It doesn't, the code base is not closed compared to closed software that's only the company has access to those code base. But for AI models, they are closed models and they are open weight models. They are not open source models. They are called open weight models. So it means that the weight of those models, the models you can host them yourself. You have access to download those weights and host them yourself, right? So, but this Minimax, so the GPT models, the Gemini models, the Opus models, they are closed weight, they are closed models, they are proprietary models, right? So it means that nobody can have access to their weights. You can't know how their training looks like. You just only get it based on the outputs, right? So those are the closed models. For the open weight models, we have several companies that create open weight models. And funny enough, most of the major open weight models are coming from China, and they are really trying to fight the market and try to bring down closed weight models. Because you can see here now, for programming from open router, so this does basically open router does basically tracks the number of requests that is being made via open router, right? It's not generally like for calls, but this is via open router. And open router is like the major hub where houses all these models that you can get API. So open router has an API where it provides people to use these models via their API, right? So it means that on open router, Minimax 2.5 is the highest used, is the most used for programming, 656 billion tokens, followed by GLM5, which is also an open weight model from China. Minimax is from China, ZDI is from China. GLM5 has used 235 billion tokens already. That is now followed by this is now the first closed source, proprietary model, Opus 4.6, right? Which is not even get up to 4 times Minimax level of usage. Then the next one, number 4, is not a closed model. So PDK 2.5 by Motion AI is a closed model. Then followed by Solid, Minimax 2.1. This Minimax 2.1, I think for Minimax, this was when the model was doing extremely well. Or that was where people could see the capabilities of the Minimax model, and people that started using it. That's why you can see that 2.5 is now ILB, because people enjoyed using the 2.1 model. I enjoyed using the 2.1 model, but when they launched the 2.5, it was more of like a step up to that. So, but let's go back to our task. Let's see how far. Okay, it's terminated. Operation was permitted. Wonderful. So, okay, I think this one might be what is a lot of this, and it should be able to continue. I think it's just rerun this particular command. So let's see if it will figure out that it's supposed to rerun that particular command. So it's trying to install. Let's see whether it will get fast. I just install it myself for the Claude models. So these are the give and takes that you get from all these models. So now the thing with all these open weight models is that they are usually extremely cheap, right? They are cheap to run. So you can see the Minimax costs 30 cents per million inputs and $1 per million outputs, compared to what GPT 5.2 is giving $14 per million outputs, which is crazy. But now, not just even that, in terms of in terms of speed, the Minimax models are fast, because of this was just launched recently, right? So the different throughputs for these model, because the different providers for this model, they are still trying to adjust their system to make sure that this model doesn't run fast. But from here now, you can see that you can get up to 135 tokens per second on for minimax, right? This is what you can get if you are using Sound Nova, right, to get access to this model. So you are getting extremely fast speed. But for 5.2, the highest you can see here, because of it's only OpenAI and Azure, right, which is Microsoft, you can see the highest they're getting is 43 tokens per second, which is nothing compared to 138 tokens per second. So these open weight models, they are, even though they are not as intelligent, but they are fast, and they are, to some extent, they can do basic things that you might want your models to do. So that's just what it is. So let's see. Okay, it's still running the command. If I'm charged API pricing, right? Because this different model. So the API pricing is this is the API pricing, right? This is for GP 5.2. This is API pricing. 14 million per $14 per million output tokens. If I go to the Opus 4.6, if I'm using API pricing and I'm running this thing now, at this point, they would have charged me somewhere close to $25, right? It's crazy. Cost a lot, but with all those other models, they're usually cheaper. So, and it's still running. So Opus models are willing to run forever. They are waiting. Okay, so now, okay, I think I finished the command, so it will continue running from here on. So, but all the Opus models are willing to continue running because they are designed to run for longer, for long running tasks. These models are designed for long running tasks. The Opus models, the Codex models, they are designed for long running tasks. So now I think it's trying to figure out whether it has set up everything or not. Let me restart the TypeScript server. So make sure that everything adjusts well. Yeah. So you can see it's still running several commands. Opus is still trying to figure out, because initially the one step is skipped initially of not installing the node modules, installing the dependencies at the beginning. It messed up what it's trying to do. So it's still running. It's trying to run commands, trying to fix whatever it has done. So now at this point you can see that it's trying to remove the node modules and try the reinstallment again. So let me just stop it here. I'll tell you to use PNPM so that it doesn't take too much time. Let me tell you to use PNPM and see how it's going to proceed. So you should be able to install faster from here on. Okay. So it's installing now using PNPM, so it should be faster in installing the dependencies. So, but normally these AM models, they don't usually default to PNPM, they just use a NPM. So, but let's go back to Codex has just been here waiting. So let's keep all the changes. Codex has just been here waiting. So now the follow-up prompt I want to give these AI models, right, is to improve the user interface we did. Currently now the Codex model has built this. So it has built this. So, but I want it to improve the UI. So I'll just tell it, make this UI much more better and improve the layout. So what I want you to do now is to improve the user interface, make it much more lively, make it more modern, make it more standard, make it look better, improve the layout, right, and add more elements to the page. So yeah, these are the two prompts I'll give you. But let's Codex be running its own task for now. So let's see how the Codex will proceed. Claude, on the other hand, if Claude now is now fixing the issue that it had initially. That's what he's doing now. So you can see he's creating a footer. He didn't create footer initially before. Even though so yeah, it's a footer already exists. So he's trying to run build now to proceed. So you can see the Codex model has already started his own. Let me keep this prompt here for Claude. So once he's done, I'll run it and it will continue. Well, no. So Codex is running. Now you can see it's updating the page, it's updating the UI for the initial version that it did. So this is the initial version that Codex did. So let's see how it's going to improve this UI to make it much more better based on the prompt I gave it. So this just shows you how these models tend to behave as regards to UI, and so this is the UI test. maybe later or in next video, I might do a backend test, or maybe not necessarily a backend test, but more of like a backend test where we'll test how it will work in terms of building and setting up backend projects. So the Claude has finished testing it, so it has tested and found out that okay, there is no issue. So now it's trying to run the command to start to listen. Okay, no, so Claude never run it in the directory where the code base is. So I was surprised that the Claude model is even being as bad as it is now. But I mean, it is what it is. So it's Claude is, like I said before, Claude is much more eager to do things. So if I make mistakes along the way compared to Codex that takes its time to make sure that it does what he specifically tells you to do. So that's the difference between the two models. So let's see how far Codex is going. Okay, Codex is still writing. So I can see that he's writing a very large patch. Okay, it's done. It has finished editing the file. Let's see if it's making any more changes to it. Okay. I think Claude gave me an alert now to run dev. Yeah. So now it's now running the command in the actual direction, which they didn't notice before. So that's it. So yeah. So now we have this. So our backend. Sorry, I say our backend. Our UI website for Claude is running. So let's see. This is Codex has already made some changes to their own. So you can see now we now added more elements, it added more liveliness to the website. So you can see it added more of like a purple dots here. I don't know why it added. Okay, it added another color green shadow here too. So I don't know why it decided to do this. So you can see it added more around there, added borders around the navbar. So it added more elements here, improve this. So I mean, it didn't do much actually. The models didn't do much. The Codex model didn't do much. So this is what I mean when I say that Codex, it makes sure that it doesn't overstep its boundaries, right? It doesn't overdo what it tells you to do. If I told it maybe do something else or do this, I've done it, but it didn't do it because I didn't specify it. It's much more careful in what it does. That's why I prefer using Codex for backend related tasks, because it's much more careful in what it does, right? So yeah, so that's what it did here. It didn't overstep its boundaries. It just did based on the instructions, right? So let's see so this is what Opus creates. So this is why I said Opus is very, very good at front-end design, right? This is a stunning website, like extremely good website. So you can see it added the font. So like I mentioned initially, right? Codex didn't actually get the fonts. It just used the default font. I don't know what font this is, but this is good. This is nice. This is beautiful. So you can see it added the fonts to the logo here, added this the nav bar, the buttons, and the fact that the buttons, the theme now lies with the background. Is the background image moving? Okay, you can see. So I don't know if you can see it, but the background image is kind of zooming out, right? The background image is zooming in and out slightly. I don't know if you can see it, but this is very good. So you can see it shows. So it now gave you like a section here to scroll. So you can see it tells you scroll and added some. This is beautiful, right? This is you won't see. This is why I said. This is why I've always said AI is not going to. It's not one of those things where it's going to come and replace, right? It's not one of those things where it's not going to. It's just going to fade out. AI is here to stay, but it's either going to make your job better. AI is supposed to make your job better, right? This is beautiful. So if people added the fading, right? When you scroll down, it added the fading. The fonts is on point. So you can see added. So this I don't know if all these are not clickable, but this just shows like in mini section, then selected works, portfolio. So this should be clickable. All these are meant to be clickable, but I don't know why it's not clickable. But you get the idea of what it's trying to do, right? So from here now, you cannot do some further prompting to make it much to maybe add some extra. Maybe if you want like a pop-up, you can tell it, okay, make all these images pop when you click on them, like a slideshow somehow. So this is good. This is very good. See that? This is very, very good. All these images are black and white, but when you hover over them, their colors tend to show. I mean, so this portrays a photography website, right? What I offer. So okay, so this is just a wow. This is good. This is extremely good. Kind words. Get in touch. So you see what I'm saying, right? Codex will not do all these things because number one, we did specify that they should do it, and it's more of like the developer that is more reserved and just willing to do something and make sure that that thing works. So if you tell it go here, it will go there and make sure that okay, or if you tell it do this, tell it make sure that it does that thing very well. But obviously, if you tell it do this, it will do it, right? It will do it. Then it's supposed to now look around and say, okay, what are the other things that can be made better based on these changes I've made, or what are the other things that should be there? You understand, or that the person might suggest I do, and sometimes he does it, which is what Opus did here. Although there's a weird cutting out of the letter L, I don't know why, but this is good. This is very, very good. So yeah, and added the footer. All this in one in although technically it's one prompt. Technically it's not one prompt, but I mean it's one prompt basically, right? Although I had to like fix and to like steer it in the right direction, but this is what Opus can generate, right? For you as a front-end developer. So there are different models that can do several things. You know, AI is here to make our job easier, right? It's here to make our job easier. I don't believe AI is going to replace developers anytime soon, or the current way AI is moving, right? It's still not looking as though it can replace the developers because there are a lot more things that goes into developing software that these AI models either tends to look over or doesn't know how to behave around them just yet. Those are the two sides of the coin that we have now with AI models in software engineering. So this is actually a very fun. I enjoy this UI a lot. This is a very, very good user interface. Probably maybe I can give this user interface to one of my friends, but this is very, very good, very, very good design interface. So yeah, I think that's basically it. I wanted to just use this video to show you um how I use AI models. Although I don't use these models in this particular way to do through websites, I usually have like a style in my head. So when I'm maybe building designs or building front end designs, I usually have like in my layout. I usually feature I come up with my layout and how it's going to look like I do these models, because if I don't specify those layouts, the models can do whatever they feel like. They hallucinate a lot. These models hallucinate and they just go on their spiral and doing random things. So this is actually how these models behave. So when you are building your software, if you know maybe which models are good for which specific type of tasks you are doing. If you are doing large tasks, maybe large project tasks, you can use the GPT models, the Claude models, the Gemini models. Even to some extent, you can use the Grok models, right? They do well for all these large, long-running tasks. But if you are doing maybe small tasks, small minute tasks like reading data, passing JSON, reading a file, you can use all these smaller models like the Gemini Flash model, which is a smaller version, which is like a lower version of the Gemini Pro model. So it's a much more lighter model. There are the open weight models from China, which is the Kimikesu, the Millimax, the GLM models. All of them, they are usually good for maybe minor tasks and all of that. So yeah, I just wanted to show you how these models behave, and probably in the future we can even do much more comparisons, right? This is one UI comparison that we did. We can do much more, and I'm excited to show you how I use these models in my day-to-day work, and show you just basically to talk about all of this. So I'm really excited. Thank you all so much, and see you in the next video.